All right. Let's talk about Lewis and acid bases. Lewis acids and can't draw that fancy and bases. Okay. Lewis, so we know what a Bronsted-Lowry acid base is that it's a proton donor. As you should learn somewhere in Reactivity 3.1 or 2, I forgot. But that Bronsted-Lowry donates or accepts protons, whereas Lewis acids and bases, it's about electrons. Okay. Let's open my notes. So it talks about the transfer in electrons. So you have a lone pair of electrons, E minus, drives reaction. Okay. It's a topic where the questions can go crazy, but the concept is really simple. It's a really short concept. So a Lewis base, I'm just going to draw base. I'm just going to write base. Lewis acid. Okay. A base is electron rich. What that means is that it donates lone pairs. Okay, Lewis acid is electron deficient. So it accepts lone pairs. Okay. So as long as you have a lot of a lone pair, it's basically a base. If it doesn't have enough, or the valence shell is not full, doesn't have a full octet, then it is an acid. Some examples are metal cations. So if we open a periodic table, there's like Al, Mg, these are all electron deficient, okay? So as long as it's a metal cation, it is a Lewis acid. Another example in organic chem is carbonation. Carbonation, which is a reaction, or carbonyls. They are all acids too. Okay. Are you sure it's carbonations? Sorry, give me a second. Oh, this is really bad. Cations. Oh, carbocations, not carbonations. Carbocations. Sorry about that. Carbocations, so a C plus and carbonyls. And then that is really it. Something to keep in mind is that the reactions are nucleophilic reactions, the nucleophile attacks, because of the electrons. You should know that already. And a comparison between Bronsted-Lowry acid, Bronsted-Lowry acid or base, and Lewis acid or base, is that all Bronsted-Lowry base acids and bases, all Bronsted-Lowry acids are considered Lewis acids. However, not all Lewis acids are Bronsted-Lowry acids. Remember that Bronsted-Lowry, he deals with the transfer of a a hydrogen ion or a proton, and therefore there will be electron transfers in that too. But then if you have an electron transfer, that doesn't necessarily mean that there is a change in protons. It could be the same. Okay, and same thing with bases too. A Bronsted-Lowry base, so base and acids equals to a Lewis acid. But not all Lewis bases in acid equal to a Bronsted-Lowry acid or base or acid. And yeah, it's nucleophilic reactions, meaning that the nucleus is what attracts a reaction. Let's have some examples here, okay? So let's say there's Fe2 plus and 6H2O react forming okay. So let's see what happens here. This is a metal cation, and this is a base because it's electron rich. Because of the O has lone pair, actually has two lone pairs, the H and H. So there is clearly extra electrons. However, the Fe, it's not at a full octet, so if I'm right, I'm not really sure. But you get the point. The Fe doesn't have full octet, means that's electron deficient. So if we go back here, an acid accepts lone pairs and a base donates lone pairs. So go back to this equation. The O would donate its lone pair there to the Fe, and the Fe would accept it. Thus, this is the iron cation. Iron 2 cation is a Lewis. Wait, go back again. Accepts lone pairs, yeah. Is Lewis acid, and the water is a Lewis base. And that's it for Lewis acids and bases.